Okay, so today we are going to talk about the properties of a rhombus. A rhombus is a quadrilateral, which we've already discussed, is a four-sided figure. In the last lesson we discussed a parallelogram, which was a four-sided figure that had two sets of parallel sides, as well as these four properties. We had properties of the sides, and we knew that opposite sides were congruent. Properties of angles that stated opposite angles were congruent, and consecutive angles are supplementary. And then properties of the diagonals, which stated that the diagonals bisected each other. Today we're focusing on a rhombus. A rhombus is a parallelogram, so all of the properties of a parallelogram are true for a rhombus, but there's also additional properties that are special just for a rhombus. The first one is the property of sides of a rhombus. A rhombus is a parallelogram with four congruent sides. So everything is true of the sides in a parallelogram. So in a parallelogram we learned that opposite sides are congruent. This is also true in a rhombus. Our opposite sides are congruent. And same here, these opposite sides are congruent. That's true, but they all are congruent to each other as well. And that's only in a rhombus. That will not happen in a regular parallelogram. So that's what makes a rhombus special, is that it's a parallelogram that has four congruent sides. The next property is the property of the angles. If a parallelogram is a rhombus, then each diagonal bisects the pair of opposite angles. So the property we learned for a parallelogram is that our opposite angles are congruent. So we learned our opposite angles are congruent. Now the special property for a rhombus is that when we draw our diagonal in, the diagonal now bisects those congruent angles. So while I had a pair of congruent angles, now my angles are being bisected. So this angle is now congruent to this angle because the diagonal cut it in half. And this angle is congruent to this angle because the diagonal bisected it. And that's also true for our red pair of opposite angles. So again, with our diagonal being drawn in, our diagonal is now bisecting that congruent pair of opposite angles. And so now we have this angle being congruent to this angle, and this angle being congruent to this angle. So now we get pairs of opposite congruent angles that are also being bisected by the diagonal, and that is a special property for just a rhombus. The last property is a property of diagonals. So if a parallelogram is a rhombus, then the diagonals are perpendicular. So again, a rhombus means that all four sides are congruent. And if we draw in our diagonals, we get the special property of a rhombus that the diagonals intersect to form a 90-degree angle. And all of the angles that are made or formed by those diagonals are going to be 90-degree angles. So we kind of get this little section of 90-degree angles in the middle of our rhombus. Okay? So we have the four properties of our parallelograms and three new properties for our rhombus. The property of the sides, that they're all congruent. The property of the angles, that the congruent angles are being bisected by the diagonal. And the property that the diagonal crosses to form right angles. So now let's use those properties to try and find some measures in this diagram in our example 1. In part A, we want to find angle DAC. So here we have measure DAC. We're looking for this angle. We know that BAC is 53 degrees, and the property of our diagonals the property of our angles stated that the diagonal is going to bisect the angle. So we know that these are being bisected. So whatever BAC is, DAC will be the same. So we really don't have any calculations. We know that DAC is 53 degrees. Part B wants us to find the measure of angle ABD. So we start at vertex A, we go to B, then we go to D. We're looking for this angle. Now, quickly glancing at it, it seems like we might not have enough information. I can see that ABE is part of the triangle, and I do know that one of the angles is 53 degrees, but there's really nothing else that can help me find ABE using the information that I'm given. So I have to think back to my properties. What properties do I know? Is there anything about my sides that's going to help me find this? No. Is there anything I know about the angles that's going to help me? Not really, because I don't have enough information to use anything to help me with my angle properties being bisected. But the property of diagonals told me that when my diagonals intersect, a 90-degree angle is formed. So now I have two angle measures of this triangle, which can help me find the third. So I can say 53 plus 90, because of my diagonals, plus my unknown angle x, is equal to the sum of all the angles of a triangle. When I add my like terms and subtract from 180, I get 37 degrees. So I was able to find that missing measure. And now, using those two measures, 53 and 37, we know every angle of this figure. I know that 37 is being bisected by this diagonal, so this is 37 and 37. I know because of parallelogram, my opposite angles are congruent, so these two are 37. I also know the properties of a parallelogram that these opposite angles are congruent, so these are 53 and 53. And because the properties of a rhombus, all of these angles are 90. So I have found all of my angle measures using my properties. Now we're going to talk more about side lengths. So part C, they want us to find DB. So DB, they want us to find the entire diagonal. And it's hard to see because this diagram is getting a little crowded, but DB is the entire diagonal, and we were told DE is 8. So we know half of the diagonal. Remember that a property we learned yesterday was that the diagonals of a parallelogram bisect each other. So I know that this is congruent to this. So if DE is 8, then EB must also be 8. And therefore DB is just 8 plus 8, or 16. So that's just using our properties of a parallelogram, but it is showing that those are still holding true on our rhombus. We're going to find AE, segment AE, which is right here. Right? And now this is going to require a little bit more work. Right? Our AE. Let's redraw this triangle. I have a right angle. I know 53 degrees is in this angle. I know 37 degrees is in this angle. And I'm trying to find this unknown. And I know that my side over here, which was part of the diagonal, is 8. I want to find this side. I do have a right triangle, but I can't use Pythagorean theorem because I only know one of the sides. I can't use 30, 60, 90, or 45, 45, 90 because my angle measures just don't allow it. So all I'm left with is my SOHCAHTOA. I have to use some trig to help myself find this measurement. Now, I know 53 and 37, so I have some options here. There's not only one correct trig answer like we've seen in the past, because now we have some options. So we can start with 37 or 53. I chose to go with 53, so I'm using 53 as my starting point. And then I want to set up my trig ratio using the information I have. I know I want to use the opposite side, and I want to use the adjacent side. I don't have any information about my hypotenuse, so I can't use sine, I can't use cosine, so that requires me to use the tangent of 53 is opposite over hypotenuse, and now I'm going to solve for x by multiplying on both sides, divide by the tangent of 53 on both sides, which leaves me with x equals 8 divided by the tangent of 53 gives me 6.02, so if we round, it's really just about 6. So going back to our diagram, right, AE is 6. And again, using the property of our parallelogram, we know that this segment will also be 6. So AE is 6. So there's a little bit more work involved in that. The last step is to find the perimeter of ABCD. So again, we know that this is a rhombus, therefore all the sides are congruent. So once we find one of the sides, we know all of them, then we can find the perimeter. Right? So this is another kind of trick. There's a lot of information here. We kind of need to step back and say, what information can I use? Just like we did to find our segment, we can pull one of these right triangles out. And we could say, okay, well, here's a right triangle. I know that this side is 8. I just found that this side is 6. So, how can I find this side? Because once I know this side, then I have all the other sides, and I can find the perimeter. Right? So, what can I do to find the side? Well, here we do have two sides, so if I need to, I can use a squared plus b squared equals c squared. Hopefully we recognize that this is a triple, but if not, we can calculate just as easily 6 squared plus 8 squared equals c squared. 36 plus 64 equals c squared. 100 equals c squared. We square root and get 10, which a 6, 8, 10 triple is a very popular triple that we hopefully recognize. So now once we have found that that side is 10, we can go back and plug that into our diagram. I know that this is 10, BC is 10, DC is 10, and AD is 10. So therefore, our perimeter is 10 times 4, or 40. So we're going to see a lot of different applications of the rhombus because we do have this right angle component of a rhombus. We do see a lot of the review from what we just did in the last unit with our trigonometry and with our Pythagorean theorem, and even sometimes with our 30, 60, 90 triangles or our 45, 45, 90 triangles. So be on the lookout for those properties. When you seem stuck, think back to what do I know about a right triangle. So make sure you have these notes and these examples in your, the properties and the notes and the examples in your notes so that you can come to class and be ready to practice. See you then.